Sun. The Sun is the closest star to Earth and is the center of our solar system. A giant spinning ball of very hot gas, the Sun is fueled by nuclear fusion reactions. The light from the Sun heats our world and makes life possible. The Sun is also an active star that displays sunspots, solar flares, erupting prominences, and coronal mass ejections. These phenomena impact our near-Earth space environment and determine our space weather. The Sun is the most prominent feature in our solar system. It is the largest object and contains approximately 98% of the total solar system mass. 109 Earths would be required to fit across the Sun's disk, and its interior could hold over 1.3 million Earths. The Sun's outer visible layer is called the photosphere and has a temperature of 6000 degrees centigrade. This layer has a molten appearance due to the turbulent eruptions of energy at the surface. Solar energy is created deep within the core of the Sun. It is here that the temperature, 15 million centigrade, and pressure is so intense that nuclear reactions take place. The energy is released as light and heat. Energy generated in the Sun's core takes 1 million years to reach its surface. Every second, 700 million tons of hydrogen are converted into helium ashes. In this process, 5 million tons of pure energy is released. Therefore, as time goes on, the Sun is becoming lighter. The chromosphere is above the photosphere. Solar energy passes through this region on its way out from the center of the Sun. Faculae and flares arise in the chromosphere. Faculae are bright luminous hydrogen clouds which form above regions where sunspots are about to form. Flares are bright filaments of hot gas emerging from sunspot regions. Sunspots are dark depressions on the photosphere with a typical temperature of 4000 degrees centigrade. The corona is the outer part of the Sun's atmosphere. It is in this region that prominences appears. Prominences are immense clouds of glowing gas that erupt from the upper chromosphere. The outer region of the corona stretches far into space and consists of particles traveling slowly away from the Sun. The corona can only be seen during total solar eclipses. The Sun appears to have been active for 4.6 billion years and has enough fuel to go on for another 5 billion years or so. At the end of its life, the Sun will start to fuse helium into heavier elements and begin to swell up, ultimately growing so large that it will swallow the Earth. After 1 billion years as a red giant, it will suddenly collapse into a white dwarf, the final end product of a star like ours. It may take 1 trillion years to cool off completely. Stars are born. They take shape. They go through a turbulent adolescence, and then they live out their lives in a predictable pattern. Some have companions to provide for. Others rapidly decline and die. Sunspots are places on the surface of the Sun where the magnetic field is much stronger than normal. Sunspots only appear near the Sun's equator, between about 40 degrees north and 40 degrees south latitude. Sunspots never appear near the Sun's poles. The Sun is not a solid object. It is a giant ball of gas and plasma. Some parts of the Sun rotate more slowly than other parts. At the equator, the Sun spins pretty fast. It takes 25 days to turn all the way around. It turns more slowly at the poles. The poles take 34 days to spin around once. The solar wind is different at the poles. It blows much faster above the poles than it does above the sun's equator. Solar eclipse. An eclipse of the sun occurs when the earth passes through the moon's shadow. A total eclipse of the sun takes place only during a new moon, when the moon is directly between the sun and the earth. When a total eclipse does occur, the moon's shadow covers only a small portion of the earth where the eclipse is visible. As the moon moves in its orbit, the position of the shadow changes, so total solar eclipses usually only last a minute or two in a given location. In ancient times, people were frightened by solar eclipses. Now, eclipses are of great interest to the public and to astronomers. Eclipses provide an opportunity to view the sun's outer atmosphere, the solar corona. If you ever get to view a solar eclipse, make sure to never look at the sun directly. Always use one of these safe techniques. Uranus. Uranus, the seventh planet from the sun, has its spin axis almost in the plane of its orbit about the sun. This produces unusual seasons and also causes unique magnetic and electric field structures. Uranus has a faint ring system and 27 known moons. Uranus interior. The giant planets do not have the same layered structure that the Earth-like planets do. Their evolution was quite different than that of the Earth-like planets, and they have much more gas and ice inside. Uranus' interior is primarily made of methane ice. Motions in the interior of Uranus help form the magnetosphere of Uranus. Heat generated within Uranus helps form the unusual winds of the atmosphere. Uranus atmosphere. The plain aquamarine phase of Uranus confirms the fact that Uranus is covered with clouds. The sameness of the planet's appearance shows that the planet's atmosphere is mostly composed of one thing, methane. The planet appears to be blue-green because the methane gas of the atmosphere traps red light and does not allow that color to escape. Beside clouds of methane crystals low in the atmosphere, smog composed of ethane is also present high in the atmosphere. The cloud particles constantly recycle themselves, first creating, then destroying the heaviest crystals. This is an indication that Uranus' atmosphere is still evolving from its formation out of the solar nebula. Because Uranus lies on its side, Uranus has very strange seasons. Motions in the cloud patterns indicate that, like Jupiter and Saturn, the basic weather of Uranus can be described as a striped pattern of winds. This means that even though the pattern is hard to see, Uranus is striped just like Jupiter and Saturn. Uranus magnetosphere. The magnetosphere of Uranus is medium-sized, but still much bigger than the Earth's. It holds all of Uranus' moons. It is probably made in the middle of the planet and with ice rather than with iron at the core. The magnetosphere of Uranus has a very strange tilt. The extreme tilt combined with the extreme tilt of Uranus itself makes for a completely strange magnetosphere, one which has twisting structure. Mathematical theory suggests that the rings of Uranus sweep the particles in the magnetosphere into the atmosphere. The aurora on Uranus is difficult to detect, and so are radio signals from Uranus, which means that the magnetosphere of Uranus may be almost empty. Uranus moons and rings. Uranus has 27 fascinating moons and a complicated ring system. The ring is a completely different form of ring than the one around Saturn or Jupiter. At Uranus, there is a very obvious partial ring or ring arc. Many moons are icy moons with fascinating surface features. These icy moons have neither atmosphere nor magnetosphere. The interiors of these moons are not active, and there is not much possibility for life. The moons are, in order: Cordelia, Ophelia, Bianca, Cressida, Desdemona, Juliet, Portia, Rosalind, Belinda, and Puck. These moons are part of a group called the small moons. Venus. Venus is the second planet from the Sun and is Earth's closest neighbor in the solar system. Venus is the brightest object in the sky after the Sun and the Moon, and sometimes looks like a bright star in the morning or evening sky. Fair but inhospitable Venus, a sister planet to the Earth that is very different from our home. Venus does not have any moons or rings. Discover Venus. Venus is one of the brightest objects in the sky, so it is clearly visible to the naked eye. It can be tricky to spot because it is always near the Sun. Because of this, it rises and sets with the Sun each day. No one knows who really discovered Venus, since it is so obvious in the sky. However, much has been discovered about Venus in the past century. Robert Richardson noticed that Venus rotates backwards. In other words, on Venus, the Sun rises in the west and sets in the east. Mercury has only been visited by one spacecraft, but Venus was much luckier. The United States and the Soviet Union were competing to send probes to Venus. Almost everything we know about the planet came as a result of this race. We now know that Venus has a very dense atmosphere that consists mostly of sulfuric acid and carbon dioxide. The surface of Venus is very hot, reaching temperatures of 900 degrees Fahrenheit. Even today, we are still exploring our neighbor planet. In 1990, the Magellan spacecraft began mapping the surface of Venus. The spacecraft revealed volcanoes, craters, and the absence of water. Venus, inside and out. The planet is slightly smaller than Earth, and its interior is similar to Earth. We can't see the surface of Venus from Earth because it is covered with thick clouds that strongly reflect sunlight. However, space missions to Venus have shown us that its surface is covered with craters, over 1,600 major volcanoes, mountains, large highland terrains, and vast lava plains. The atmosphere of Venus. The atmosphere of Venus is very hot and thick. You would not survive a visit to the surface of the planet. You couldn't breathe the air. You would be crushed on by the enormous weight of the atmosphere, and you would burn up in surface temperatures high enough to melt lead. The atmosphere is composed mainly of carbon dioxide 96%, 3.5% nitrogen, and less than 1% is made up of carbon monoxide, argon, sulfur dioxide, and water vapor. In ancient mythology, Venus is known as the goddess of love and beauty.